Hey everyone, you are either watching this because you were absent or you are at school and I have a sub today. So hopefully, this is definitely one of the notes I wish I could do in person, but I'm going to do my best to cover it the same way on a video. So before we start, I want you to pause the video and try this warm-up question. You should be able to do this, but I want you to write a balanced equation. So from the graph, I did put some numbers to help. So A is starting at molarity 0.4 and goes to 0.36. B goes from 0.4 to 0.42, and C starts at 0.6 and ends with a concentration of 0.62. So you should use that to help you balance the equation. I want you to write the K expression. So K equals what divided by what? Solve for K, and then tell me what does K mean. So are the reactants favored at equilibrium or are the products favored at equilibrium? So pause the video right now. I'm going to put the answer up in 3, 2, 1. All right, so hopefully you got 2A makes B plus C. The reason that is because A was changing by 0.04 and B and C were only changing by 0.02, so this gets a 2 in front. Our K expression is the concentration of the products divided by the concentration of the reactant. A is squared because of that 2. And then to solve for K, I shaded the graph here. Where these graphs level off, that is equilibrium. So I'm going to take the molarity of each at equilibrium. So 0.42, 0.62, and then 0.36. And don't forget that guy is squared. And I get K equals 2. Because K is bigger than 1, that means the products are favored at equilibrium. And look at the graph. I see that in the graph. B and C are both products, and they end with a higher molarity than A. So really around like this flat area that's shaded kind of in this orangey color, we are at our equilibrium. And we know from that last problem, the products divided by the reactants is our equilibrium point. But isn't K just a ratio, right? Products divided by reactants. Yes, I've been plugging in numbers from these flat lines, but what if I wanted to plug in where these stars are? What if I wanted to know what the ratio is at that point, or at the beginning of the reaction? What if I wanted to know? Isn't K just a ratio? Does it always have to be when those lines are flat and at equilibrium? So the answer is no, you don't have to only plug in for equilibrium. The reality though is if we are at equilibrium, we are going to, or if I'm plugging in molarities at equilibrium, we are going to call this ratio of products divided by reactions K or KEQ. So when I plug in molarities at equilibrium, it's K. But I can take this ratio, products divided by reactants, at any time I want, and that is called Q. So it's the same ratio, but that is just when we plug in not equilibrium concentrations. Q is called the reaction quotient, and so it's when we use that equilibrium expression, but we're not at equilibrium, and that is the important point here. We're not at equilibrium. So maybe it's a certain point in the reaction, maybe it's at the beginning, maybe I've added something new and I want to measure where we're at, okay? So here's what I would like you to do. Use these numbers right here and solve for Q. Pause the video. Okay, so Q is, that's not what I want. Try again, Butler. Is going to be equal to, it looks like at the beginning, my B, which is this, is 0.4. My C, which was this line, is 0.6 divided by A squared, which this guy is my A, which started at 0.4 squared. So if I plug all that in my calculator, good thing I did it ahead of time, I get Q is equal to 1.5. Okay, don't forget before, so we have Q as 1.5. Before when we solved for K on the last slide, we said it was 2.0. So let's compare Q to K. K is 2, Q is 1.5. So that means Q is less than K. And here's what this means. At the beginning of the reaction, because Q is less than K, the reaction is going to proceed to the right. Okay, so because Q is less than K, we're going to move towards K. So here's what I mean. Reaction shifts right. So that means when the reaction starts, we're going to start making products. And so that means the concentration of the products is going to go up. The concentration of the reactants is going to go down as that reaction shifts to the right. So we're trying to get to this K. In order to do that, we need to shift to the right. Okay, so when we solve for Q, it can be at the beginning of the reaction or at a certain point in time. If Q is bigger than K, it means the reaction is going to proceed left. So we're always trying to get to K. So if we go to the left, that means when we're trying to get to our K, the concentration of the reactants is going to go up. The concentration of the products is going to go down. So basically, the reverse reaction is happening until we get back to our K. If Q is less than K, like the problem we just saw, we're going to shift to the right. So the reactants is going to go up. The reactants is going to go down. The products is going to go up. So basically, the forward reaction is going to happen until we get back to our K. So essentially, we're always trying to get back to this special case of equilibrium, which is called K. So I think of this as like a number line. How do I know which way we're going to shift? Well, if I put Q on a number line, it was 1.5. If I put K on a number line, it was 2.0. So I just have 10 and negative 10, whatever. You put these on a number line, we always are trying to get to K. K is the goal. We want to be at equilibrium. So if you look at your number line, to go from 1.5 to 2, I have to shift to the right, which means the reaction shifts to the right. The forward reaction is happening until we get back to that special place of K. All right. I'm going to connect this to a little bit of brain chemistry, and this is really the part of the notes I wish I was there to do. But I would like you to pause this video and go and watch. There's a link on Canvas that says Inside Out Video Clip. Here's the link if you hate yourself and you want to type it in. I would just go to Canvas. I want you to pause this video and watch the clip for me. Okay, so hopefully you watched that clip. And to me, equilibrium really ties in with brain chemistry. Okay, so here's my thinking. Everybody has their own K value, their own equilibrium. That's like when you're in your groove, right? Everything's rocking and rolling. But we need to respect not only where people's Ks are at, like where are people when they're feeling good, but we also need to respect where they are at, right? Because a lot of time, especially this year in particular, a lot of people aren't at their K. This is not the best year for everybody. So if we're not at our equilibrium, not only do we need to respect that maybe people aren't there, but that we need to meet them where they're at and understand that they're trying to get to K and maybe they're struggling through that. So we have to respect Q, where people are at, and that they're trying to get to their K. So I have a little story. If you haven't figured it out yet, I have ADD, that's why I'm scatterbrained all over the place. And in the morning, I'm at my Q, right? I wake up in the morning and I'm at Q, and for me in the morning, my Q is lower than K. I'm not at my equilibrium. I need to shift, right? And so for me, I can't get there with my own brain chemistry. My brain chemistry is unable to get to K by itself. So I take medicine. I have medicine for my ADD, and until I take it every day, I cannot get from my Q to my K because my brain chemistry cannot do it on its own. A lot of you don't have ADD. You don't need to take ADD medicine, and so your brain naturally makes those chemicals to shift you from Q to your K. I need the medicine to help. Okay? If for some reason I take too much of my medicine or I drink too much Diet Coke, I limit myself to 1 a day, but if I have too much caffeine, now I'm going to be past my K and I'm trying to get back to my K. So I'm overstimulated, and so I need to do something to calm down. Eat some food, drink some water, right? Try to absorb some of that caffeine to shift back to my equilibrium, my happy place. So think of it as like Q is where you are at right in this moment, and K is that equilibrium when you're really driving and grooving. Okay, this really to me relates to brain chemistry. A lot of you are having a good year and your brain is making the chemicals to push you to K no matter what curveball is thrown at you, right? But not all of us are able to do that, and this might relate to you a lot. When I was in high school, I didn't know that I had ADD, and we were trying to figure out. I was tired all the time. I couldn't focus. I couldn't pay attention. Even softball wasn't making me happy, which was like what I did in high school. And so I went to a doctor and a therapist, and I got some antidepressant medicines, which if you've ever been on antidepressants, that's a struggle in itself, right? How do you find the right amount? And they were adding more, taking some away, because my brain was trying to get me to this K, but nothing was quite really working. And it wasn't, unfortunately, until my sophomore year of college that we figured out, yes, I probably was suffering through some depression in high school, but it was due to my ADD and not having that in control. And so it wasn't until I was in college, and this really, I would say I was a junior in high school, when I started to have these kind of fuzzy feelings, couldn't sleep, feeling like a little depressed. And it wasn't until sophomore year of college that I was able to realize that the real issue was probably my ADD. And did that maybe cause some depression? Probably, in high school. So unfortunately, that was a long time span. But here's what I want to say. Your brain will balance out. If you are feeling depressed or anxious or have things going on, it is not your fault. There is nothing wrong with you. Your brain is just trying to get you to your K, right? Mental health is all about chemistry. And to me, if it's you, if it's a friend, all we can do is respect your K, be honest with yourself, be honest with your friends, and it's okay if you are not at K right now, if you are at Q. For me, it was about 4 years of my life that I was just kind of in this weird limbo trying to figure out what was going on. Here I am now, an adult, and I am at my K most days. We all have bad days, right? But I have medicine that helps me get there, but I also have friends, family, people I can talk to if for some reason I'm having trouble shifting my Q to my K. I do take brain chemistry very seriously. Unfortunately, I've had 3 students in my teaching career take their own life, and obviously that is the most heartbreaking thing ever. Trying not to get emotional because I'm sitting by myself right now. But to me, I want you to hear that it is okay if your brain is not at K right now. I want to meet you where you're at. And I want you to hear that I promise your brain chemistry will balance out. Hopefully sooner rather than later. But for me, it took a while. But it took me being curious and being honest and talking to people, talking to my doctors, talking to my mom, my brothers, people that I trust. And so please know I am here for you. People are here for you. And just because your Q is not at K, that is okay. There is nothing wrong with you. It is just brain chemistry trying to balance out. And there might be good days, bad days, better days, but please know that it might take some outside help, whether it's talking to an adult, talking to a friend, maybe it's medicine. Okay, obviously I'm not a doctor, so I don't know when is the right time to give maybe a medicine like what I take, or an antidepressant or anti-anxiety, but sometimes our brains need a little help. Maybe it's getting more exercise, eating right? All of those cheesy things that we all know actually help, even though we're like, yeah, okay. But I just want you to hear that this is all about brain chemistry, and it is okay if you feel a little out of control with your brain sometimes. Please know, though, that we are here. I am here. Your friends are here. Everybody cares about you and wants to meet you where you're at. It's okay if you're not feeling like you're at your perfect K every single day. Woo! Butler getting a little serious today, right? Okay, I have 3 practice problems, right? Nothing like watching a little Pixar movie and then a serious talk from your teacher on a YouTube video and then practice problems. Okay, here's what I would like you to do. Write the balanced equation like we did in the warm-up. Write the K expression and solve for K just like the warm-up. Write the Q expression, which is just like K, and solve for it at T equals 0. So instead of at equilibrium, we're going to plug in the beginning numbers and compare Q to K. Compare Q to K. So pause the video, try this one, and I'm going to put the answer up in 3, 2, 1. Don't cheat. All right, so this is a triangle, so this is telling me the change. This changed 0.1 from 0.7 to 0.6. This guy changed 0.1, this guy changed 0.2. So there's my balance equation. C plus B makes 2A. My K expression is products, A squared divided by the reactants. I plug in the values for this flat line. So I plug in, solve for K. So because K is 0.5, that means at equilibrium, so at this point, the reactants are favored, meaning when we are at our happy place, there are more reactants and products. My Q expression, notice, is exactly the same, but I just put a Q instead of a K. and I'm going to plug in the initial molarities. Now that I have these initial molarities, I solve. Q is 0.0357. Picture a number line. This would be on the beginning of the number line and then 0.5, so we are going to move to the right. So the reaction from the beginning to equilibrium will shift to the right to establish equilibrium. Same thing, pause the video and try this one. All right, I got C plus B makes 2A. I plug in my equilibrium values because the K expression is the same. K is 0.5. Now I plug in my initial. So if you notice, A starts at 0, so I'm plugging that in. Q is 0, and so because Q is less than K, we will shift towards the right. We always are going to shift towards the right when Q is 0 because that means we're starting with no product, so our only option is to do the forward reaction. Just a little hint for you. And the last one, I want you to try this one. If you are getting this, you are good to go. You should be able to be successful on your problem set for the first problem set. The only questions you might not be able to answer are manipulating K, so I think it's 28. And hold on, let me just check so I don't say it wrong. So 28, 36, and 40, I want you to skip on Unit 1 problem set until Friday. So you will still do them, but not until Friday. Okay, pause the video, try this last problem. All right, hopefully you got the same answers as me. Good job, everybody. I hope you are able to get to K today.